going to proceed from where we had stopped. Still we are looking at differentiation. I told you earlier that differentiation has got very many areas. So we are going to be handling one area per area. Now, right now, we are going to look at what we term as what we call differentiation of parametric functions. So, to them, we are going to look at differentiation of parametric equations. So, that's what we are going to look at today. Differentiation of parametric equations. If you don't want to say equations, you can say functions. Still, all of them are the same. So, when you talk about parametric equation, what comes into your mind is, have you ever heard of the word parametric, or it is your first time to hear parametric? Hey, who can give me a try there? No one, all of you, it is new to you. So when we talk about a parametric equation, we say parametric equation are equations expressed in terms of a third variable. So in terms of a third variable, so we have been used of variables x and y. Now we are going to invite a third what? Variable. We can call it maybe t. So we can say parametric equations. We can say parametric equations are equations expressed in terms of a third variable. In terms of a third variable, i.e. in terms of t, i.e. you can use any variable, i.e. t, such as x equals t squared, comma, y maybe equals 2t plus 5. You can see that x is a variable but is expressed in terms of another variable t. Y is a variable expressed in terms of another variable, also in terms of t. So when you find that two equations expressed in terms of another variable, we call them their parametric equations. Then here the parametric variable is t. In these scenarios, this and this, we shall say here the parametric variable, is t. Is t. So you can see t is appearing on the variable of x. Again, t is also appearing on the variable of what? Of y. So we say the variable is t. And here in this case, when we are differentiating these ones, we normally use what we call the chain rule. We normally use the chain rule to obtain the derivatives. Of these equations, the derivative of parametric equations. So here we normally use the chain rule to obtain the parametric equation. The other time we are looking at the chain rule which we handled. So we are going to look at examples. We are going to do many as possible examples. So let me hope that you have already got that. So whenever somebody asks you what are parametric equations, simply say parametric equations are equations expressed in terms of a third variable, i.e. t. We have given an example of those equations which are expressed in another variable, and we have said that the parametric variable is t, because we have invited a third what? Part. So we are going to look at examples. Let's look at examples which I want people to be very, very, very attentive and very, very serious. Is it So we're going to look at example 1. Example 1. Example 1. Example 1. We are going to start by saying, find dy dx in terms of t. Find dy dx in terms of t, for the following functions. For the following functions. We are starting with part A. Want to be dealing with this example 1, but I'm breaking part A. We have got that y equals 3t squared plus 2t, x equals 1 minus 2t. So you can see the first variable of y equals 3t squared plus 2t, and x equals 1 minus 2t. So they want us to get the y dx in terms of this. Let's look at the solution. So the first one is given as y equals 3t squared plus 2t. Now what you do, you differentiate this y with respect to t, so that we get the y dt. So can you look at the y dt? What is the y dt? When you differentiate this one comes, you get a 16, very good, plus when you differentiate 2t, you get a 2. We have also got our x equals 1 minus 2t. We also look at the x dt. How do we differentiate this? When you differentiate 1, you get a 0. When you differentiate negative 2t, you get negative 2. So you can see we have got the y dt and the x dt. How can we get the y dx? We shall say, using the chain rule, using the y dx, x equals the y dt times dt dx. What is our dy dt? Our dy dt is already 6t plus 2 times. What is dt dx? Remember, we are given dx dt. How can we get dt dx? We just take the reciprocal. That means to get the dt dx is going to be 1 out of negative 2, because this one is already that. So what comes into your mind is becomes 6t plus 2 out of negative 2 plus, you got it. What is common up? What is in here and there, what is common is a 2 into 3t plus 1 out of negative 2. 2 and 2 crosses. What do you remain with? We remain with a negative into 3t plus 1. If you want to open the brackets, you say negative 3t minus 1, which is dy dx. You can see we have obtained dy dx from the parameters, the parametric equations which is being given. So whenever you are given that question, that's the way I'm expecting you to be doing that. So you have got that y equals 3t squared plus 2t. Then you can see y is in terms of t, which you have invited another variable, which we are calling them parametric equation. And this scenario here, t is our parametric equation. So when you first get the y dt, you differentiate this function with respect to t. Again, you also look at x is also given in terms of t. You also get the x in terms of t. That is why we are saying the x dt. We are differentiating this function with respect to t. So from there, you have obtained the y dt, and you have also got the x dt. So we can use our chain rule, what we have already said there, in order to get the y dx, such that when we say the y dx equals the y dt times dt dx, dt can easily cross remain with the y dx, and we have come out with this number. So this is how we normally, and that's what we're going to be doing several and several. So this was part A. We need to go to part B. I want to get to part B, so that by the time when we exhaust more, we are already at bar. So part bar is saying y equals 1 plus 2t cubed, comma, x equals t cubed. X equals t cubed. So we are going to look at this scenario. So our y is 1 plus 2t cubed, again x equals t cubed. So the first step is also you do the same. You differentiate y with respect to t. You differentiate x in terms of t. Then you obtain, then we use chaining rule. Let's go. Y equals 1 plus 2t, the whole of it cubed. So can we look at the y dt? How do we get the y dt? You bring 3 first into 1 plus 2t power 2. You deduct 1 times, then we differentiate inside. When you differentiate 1, you get a 0. When you differentiate 2t, you get a 2. So when you multiply, what do you get? You get 6 into 1 plus 2t squared. Then we have also got x equals t cubed. We also get the x dt. What do you get? We get 3t squared. Then from there we say using dy dx equals dy dt times dt dx plus, can we move together? What is the y dt? The y dt is already 6 into 1 plus 2t, the whole of it squared, times, when you see dt dx, remember we have dx, we take the reciprocal. We say 1 out of 3t squared. What happens with 3 and the 6 reduces? We remain with what? 2 into 1 plus 2t, the whole of it squared, all over t squared. So you have already got what we call the y dx. That's how we handle these numbers. And we need to be very, very, very careful whenever we are handling such kind of the numbers. So that's how we can differentiate some of the parametric equations. So let's go to example 2. This was example 1, and then we hope that we are now together. So we are going to go to example 2. We're going to go to example 2, and to go to example 2. I told you that I'm going to be giving you several examples, so that at the end we are just looking at these things as a walkover. So we're going to go to example 2. Is saying example 2. It goes, for the following curves, yes, for the following curves, each of which is given, each of which is given in terms of the parametric, in terms of the parametric full stop condition. Find an expression of dy dx in terms of t. Find y dx in terms of t. Part A, x equals t squared, comma, y equals 4t minus 1. Part B, y equals 2 root t y equals 2 root t, comma, x equals, no, let me change and say this is x equals 2 root t, and y equals 5t minus 4. Then part C, x equals 2 all over 3 plus root t, comma, y equals root t. So members, let's try to pay attention to these solutions. We want to be calculating all these. They said for the following curves, these are curves, the first one they are given in terms of parametric equations. So they have asked us to find the y dx in terms of t. We are starting with part A. It's saying x equals t squared, and we have also got y equals 4t minus 1. So when they give you x in terms of t and y also in terms of t, it means t is the parametric variable. So we need to get the x dt. We differentiate x with respect to t. The x dt, we are coming out with 2t. Then here we've also got the y dt. We are also getting 4. When divide 40, you get a 4. Divide 1, you get a 0. Then from there we say using the y dx equals the y dt times dt dx. What is our dy dt? Our dy dt is already 4 times. What is our dt dx? We take the reciprocal. It comes 1 out of 2t, which becomes what? 2 can go in 4, remaining with 2 out of t, which is the y dx, which is given in terms of a t, which is given in terms of a t. So let's move to part B. We are getting solution for part B. We have given that x equals 2 root t, comma, y equals 5t minus 4. So we said when we give here root, it is the same as power a half. So we have got x equals 2t power a half. Now we look at the x dt. When we differentiate this one, what do we get? We get, you bring up a half times 2t, then deduct 1, we get negative a half. 2 crosses, what do we remain with? We remain with t power negative a half, which is dx dt. We also go to y. We also have got y equals 5t minus 4. We also look at the y dt. How do we get the y dt? When you differentiate a 5, you get a 5. When you differentiate a 4, you get a 0. So we still say using the y dx equals the y dt times dt dx. So what is the y dt? The y dt, our dy dt is already 5 class times. What is dt dx? Dt dx is already t power negative a half. Now, when you said what from the rules of indices, when the power is up, you can raise it down. Even if you solve from there, you have already even got the answer. But for simplicity, take it down. 5 out of t power half. And we say the power half means the root, which is the same as 5 out of the root of t, which is the y dx. This is how you can obtain your dy dx when given the parametric equations. Then I normally tell my learners that always practice this. They are always very simple. The moment you have got a positive mindset, and remember, practicing. The more you practice, the more you become perfect. But if you don't practice, I want to assure you, even the little you have will just evaporate. So that's how we have tried to handle those areas. So we are now moving to this area of part C. Area of part C, which we want now to handle together, and we move on with it, so that at the end you achieve the best. So part C goes, our part C goes, x is 2, x equals 2 all over 3 plus root t. So there are very many ways. You can either use quotient or I can take it up. Which one do you prefer? I take it up, let's take it up as somebody else say. X equals 2 into, this is like power 1. So this is the same as 3 plus t power a half, power negative 1. So we are going to get the x dt. The x dt. If you want to use quotient, still there is no problem. So if you want to use the usual one, you can use it this way. So what do? You bring the power down. It becomes negative 2. You write exactly 3 plus t power half, power negative 2 now. That one times we differentiate inside. When you differentiate 3, you get 0. T power half, it becomes a half. T power negative a half. So what happens? 2 and 2 disappears. I remain with negative t power negative a half into 3 plus t power a half power negative 2. I can bring them down, or if all is required, I say this is the same as negative 1 out of t power half. This one becomes t power half into 3 plus t power half power positive 2. From the use of indices. I think members are getting the point. So this one becomes negative 1 all over, and this is the same as root t, okay, into 3 plus root t, very good, power 2. That is what we call the x dt. So after getting the x dt, go ahead and look for the y dt. We have already got our y. Our y is root t. That means y is the same as t power a half. We look at the y dt. What is our dy dt? Bring this power a half, t power negative a half, which becomes 1 out of 2 t power half, which becomes 1 out of 2 root of t. Very good. This is our dy dt. So after getting the y dt, then you can use, you have got the x dt and the y dt. Then we can go ahead and we use our chaining rule. We say using the y dx equals the y dt times the t dx. So what is our dy dt? Our dy dt is already 1 out of 2 root of t times. Where there is the t dx, bring this, we take the reciprocal. So this one goes up and this one comes up. So this will remain with negative root t into 3 plus root t, the whole of it squared. What happens with the root and the root? It goes. I remain with negative 1 out of 2 into 3 plus root t, the whole of it squared, which is giving us the y dx. That's how we can handle those parametric equations. I say I'm still giving more examples until when we get this concept accurately. So we shall proceed to another example. After getting these concepts, now everybody can easily do, and these questions don't miss. Come rain, come shine, in an exam, they are always there. And they are always very simple, so long as you develop a positive mindset. It is through developing the positive mindset, then the rest can be handled very, very well. So we are now moving to another example. We're going to go to example 3. We are now going to move to example 3. We're going to move to example 3. Example 3 goes, given the curves, example 3, it goes, given the curves, y equals t squared over 1 plus t over 1 plus t, and x equals t over 1 plus t, and x equals t over 1 plus t. Find the point on the curve. 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 Find the point on the curve where the gradient is 15. Where the gradient is 15. Where the gradient is 15. So I want to look at the solution. And we normally say that when they talk about a curve, the y dx is the same as the gradient of the function. It's the same as the gradient of the curve being given to you. So for this case now, they have said that the gradient is already 15. What comes into your mind, that means the y dx is given as 15. But now we need first get the y dx in terms of the t, which has been given us. Remember, we have those parametric equations. Let's move now. I've got y equals t squared over 1 plus t. So you can see this one is a quotient. We first get the y dt. This is our u, this is our v. So we're going to use quotient rule. We have already said our u equals t squared. We shall look at the u dt. The u dt is going to give us 2t. We have also got v equals 1 plus t. We are going to look at the v dt, which is given as 1. So using the y dt equals v du dt minus u dv dt all over v squared. What is our v? Our v is already 1 plus t times what is the u dt? 2t minus what is our u? Our u is already t squared. What is the v dt? 1 all over v squared, which is 1 plus t the whole of it squared. What do we get? When you multiply, what do we get? We open the brackets, we are getting the 2t plus 2t squared minus t squared all over 1 plus t the whole of it squared. What does it become? It becomes 2t plus t squared all over 1 plus a t the whole of it squared. If you want to factorize out, no problem. So this is our dy dt. So after getting the y dt, we also need to get the x what? dt. We have got x given as t all over 1 plus t. The same story, this is our u, our v. We have said the u is t. We look at the u dt, you are getting 1. We have also got v, 1 plus t. We also look at the v dt, which is given as 1. Then we shall say, using the y dx, we are dealing with the x dt, using using the x dt from quotient equals v du dt minus u dv dt all over v square. What is our v? Our v is given as 1 plus t times what is the u dt? 1 minus what is our u? Our u is already t times what is the v dt? The v dt class is already 1 all over what is our v? 1 plus t the whole of it square. What do we get? We get 1 plus t minus t all over 1 plus t the whole of it square. What do we get? 1 all over, because t goes 1 plus t the whole of it square, which is the x dt. So I've got the y dt and we've also got the x what? dt. So from there, what do? We are going to use our chain rule concept. From there, we are going to use our chain rule concept. We are going to use our chain rule concept. So I'll say using the y dx equals the y dt times dt dx. So what is the y dt? The y dt becomes 2t plus t squared all over 1 plus t the whole of it squared times what is the t dx? The t dx is here, take the reciprocal. What is it going to be? It's going to be 1 plus t the whole of it squared. This and this disappears. What do you remain with? We remain with 2t plus t squared, which is the y dx. Now, they said, find a point on the curve where the gradient is what? 15. We have already got the dy dx, and we said our dy dx is the same as what? Gradient m equals dy dx. So our dy dx is already 2t. I've already got 2t plus t squared equals the gradient, which is 15. So we can rearrange this equation. What we have, we are going to have t squared plus 2t minus 15 equals 0. This is a quadratic equation. If we try to look at the product plus, can we solve this one? What is the product? Product is negative 15. What is the sum? Sum is the number here. Sum equals 2. Can we think of the factors? Think of two numbers. When you multiply them, you get negative. Think of two numbers. When you multiply, you get negative 15. And when you add, you get a positive 2. Can we think of those two numbers? What are they? Tell me. Yes, somebody has said negative 3 and 5. Negative 3 times 5, you get negative 15. Negative 3 plus that, you get a positive 2. Very good. So instead of this, we bring these scenarios. What are we going to have? We are going to have t squared minus 3t plus 5t minus 15 equals 0. So, two numbers in a bracket, two numbers in a bracket. So, what is common here is a t into t minus 3. And again, what is common there is a positive 5 into t minus 3 equals 0. So, after factoring out, we are going to have t plus 5 again into t minus 3 equals 0. What do? We say either t plus 5 equals 0. This is a positive. When the concept becomes what? A negative. So we have already got t equals negative 5. Or we have got t minus 3 equals 0. This one when the concept becomes a positive. So I've got t equals 3. We have already got two values of t. After getting the two values of t, we are free to substitute in up to get the values of y, and at the same time we also get the value of x. So can we substitute in so that we can easily get these values? So you can substitute in any to obtain the value of x, and again to obtain the value of y. So we shall start. For t equals -3, for t equals -5, for t equals -5, can we substitute and get the value of y? What will be y? Y equals, we're substituting up, to be -5 squared all over 1 plus -5. What will be y? 25 out of -4. What is y? -25 out of 4. We are again substituting in the value of x, in the column of x. When y is that, after t is that, we also substituting in the value of x. X equals t out of 1 plus t. X equals, what is our t? Is already -5. We say -5 out of 1 minus 5. What is it? -5 out of -4, which is already 5 out of 4. So what is the point now? We write x and y. What is the point? The point becomes 5 out of 4, -25 out of 4. That's 1 point. Then we also go ahead. For t equals 3. For t equals positive what? 3. We still substituting to get the value of y. What will be y? Substituting y becomes 3 squared out of 1 plus 3. What is that? That is 9 out of 4. We also substituting the expression for x. What is x? X equals, we get 3 out of 1 plus 3. What is x? Becomes 3 out of 4. What is the point? So what is the point? The point, you write x and y. What is the point? 3 out of 4, 9 out of 4. So those are the points which they wanted you to get when they have given those parametric equations, and that's how you're supposed to simplify up to the climax. So that's what we're going to be doing, all those stuffs. So we are going to do another example. This is example 3. So we are going now to move to example 4. I hope that we are moving together. Always practice these things and read them. So let's move to this example so that people can get the concepts. Very, very well, so that at the end there is no any call for another. People will have already got the whole concept. So that's how we do. I never tell you that differentiation is very simple and does not miss an exam. It is there. It is there. Every year you find it there. It is there. You just go when you know that you're going to summarize all those marks in your pocket. So we are now moving to example 4. Example 4. Example 4 goes. Find the gradient of the curve. 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 X equals t cubed plus t squared and y equals t squared minus 2t where t equals 2. They have said find the gradient of the curve. So when they say find the gradient of the curve, they want you to get what we call the y dx. And we say that the y dx is the same as the gradient of that curve which is given to you. So you need, after understanding that you are given parametric equations, and this time around you are given the value of t, what they want from you is get the y dt, also get the x dt, then from there use the chain rule to get all those derivatives. So solution, we are given x equals t cubed plus t squared. We get the x dt. How do you get the x dt? When you say t cubed, what do you get? We get 3t squared plus 2t. We have also got y. What is our y? Y equals t squared minus 2t. We also look at the y dt. How do we get the y dt? We are getting the 2t minus 2. Then from there we shall say using the y dx, equals the y dt times the dt dx. What is our dy dt? Our dy dt is already 2t minus 2 times. What is our dt dx? Dt dx, we take the reciprocal, which becomes 1 out of 3t squared plus 2t. What does it become? It becomes 2t minus 2 all over 3t squared plus 2t. If you want to factorize out, there's no problem with that. What does it become? We're getting the y dx. What is coming up is 2 into t minus 1 all over. What is coming down? You are seeing a t. You remain with 3t plus a 2. So we have already tried to factor out if you want. Then from there, they said find the gradient. And we said that the gradient equals the y dx. So our gradient m equals this 2 is equal to 2 into t minus 1 all over t into 3t plus 2. 3t plus 2. Then they said at when t equals 2. It means where there is a t, put a 2. So what is it going to be? 2 into 2 minus 1 all over 2 into 3 into 2 plus 2. What do we get? We get 2 into 1 all over 2 into 3 plus 3 times 2, we get a 6. A 6 plus that, 8. 2 goes. What do I remain with? 1 out of 8. So this is the gradient. This is the gradient which they wanted. So you can easily get the actual gradient when you are given those constants, those variables. So that's how we normally handle such a kind of the numbers being given to you. So as we are trying to now to move on, we are going to go to another concept, which is now about differentiation